Okay, second last lesson in our trigonometry unit, the sine law. Now, before we start the lesson, I just want to always remind you to go to your calculator, hit mode, and please make sure that your calculator is set on degrees. Otherwise, this is going to be a very frustrating unit for you. Okay, so sine law. Well, you've had a bit of an introduction to sine law through the ambiguous case lesson that we had. So you know the ratio already, right? So remember the sine laws for a non-right triangle, and it could be a over the sine of a is going to be equal to b over the sine of b, which is equal to c over the sine of c. If you're looking for a line segment, it's probably best to use this format. If you're looking for an angle, you may want to put the sines on top and the line segments on the bottom. When you know, the main thing you know when you do sine laws, when you have opposite pairs. So if you have this line segment and this angle opposite each other, and you want this angle and this line segment opposite. So if they're opposites one another, that's when you know you're using sine law. Other situations where this can happen is you get two angles on any side, like here, two angles on any side with opposite pairs. Or if we have this, we could find the third angle by subtracting 180 from these two and then correct the other two. So these are the three basic formations for using sine law. If you know the measure of two angles in a triangle, you can determine the third angle because they have to add up to 180 degrees. And when determining side lengths, it may be easier to use the first format where you have the line segments on top. You're using it to determine angles. It may be easier to use this one. So these are both sine laws. They're just flipped. Okay. So how to use this to calculate length? Well, here we have a diagram, and the first thing you want to do is analyze because we've got opposite pairs hanging on. So we're looking for GH to the nearest tenth of a centimeter. So we're thinking about setting this up in a way so that we can use sine law because we have the opposite side. So we've got 7.8 sine 51 is going to be equal to, now we're looking for GH, which we can also call length segment J, over sine 44. So we're going to cross multiply. We end up with J sine 51 degrees is going to be equal to 7.8 sine 44. Now, we want to isolate for J, so we're just going to divide both sides by the sine of 51. So pop that into our calculator, and J is going to end up being something like 6.97. So we could say that J, or GH, is equal to about 7.0 centimeters. Okay, pretty simple. So you guys are probably pretty good at this one from the ambiguous case yesterday. Let's go to the check. Okay, moving on to the second example. What we'll be doing here is to determine the measure of an angle. So here we have two line segments, and we want to find angle N. And we have an opposite pair here, and the problem is that we need an opposite pair up here. We don't have this angle for P, so we'll just use the idea that the three angles of a triangle have to add up to 180 degrees. The sine of 92 degrees divided by 11.8, because those are opposites, is going to be equal to the sine of P divided by 10. Cross multiply. Now I'm going to skip a step here. It'll be sine P is going to be equal to 10 sine 92. I know that these are being multiplied together, so we're going to end up in the end dividing it. So if you skip a step here, I think that's quite all right. And then we have angle P, once we pop that into the calculator, being 57.88. So we could round this off to angle P being equal to 58 degrees. Okay, so this is 58. I know that my third angle, which is we'll call angle N, is going to be equal to 180 minus 92 minus 58, and that's going to give us 30 degrees. So there's our answer. Angle N is 30 degrees. Okay, flip over to the next page and try the check for that one. Angle G to the nearest degree, and that comes out to B. I'll just dot it down here. Angle G for your next problem is going to be 75 degrees. Okay, next part has to do with a little bit of terminology. What does it mean to solve triangles? Well, you'll get the direction, solve triangle ABC. And what that means is we're going to solve for all sides and all angles. So here we have a triangle, DEF. DE is equal to 5, angle D is 80, FE is equal to 8 centimeters. Show that only one triangle can be drawn and solve the triangle. Give angle measurements to the nearest degree and side measurements to the nearest tenth of a centimeter. So we'll call this D, E, F. You know that this is 80 degrees. And this line segment comes in at 5. And this line segment comes at 8. So already we know that this cannot be ambiguous because this number that's opposite the angle is larger than the line segment that's including the angle. So the ratio is greater than 1, so this cannot be ambiguous. It's only going to be one case. Another way you can look at it is if we took line segment D and divided it by F, it's going to be greater than 1, so it's only one triangle is possible. So that's how you prove only one triangle is possible. Okay, so that determines how much work you're going to have to do for this one. So there's A. For B, we're supposed to calculate what we're solving the triangle. So we can figure out angle F. Sine F over 5 is going to be equal to the sine of 80 over 8. So sine F is equal to 5 sine 80 divided by 8. Angle F is going to round up to about 38 degrees. Okay, that's easy. Now to find angle E, that's simply going to be 180 minus 38 minus 80. So angle E ends up giving us 62 degrees. Okay, one thing left to do, and that's this line segment down here. So we'll just use the sine law. E sine 62 degrees is going to be equal to 8 sine 80, 8 sine 62 degrees divided by sine 80 is going to be equal to E, and in the end E is going to be equal to 7.1. So my triangle is now solved with all the mathematics to prove it. Okay. Go to triangle PQR and solve that triangle, please. I'll give you a little summary here. How can I do it? Here's the angles for the next one. PQR. All the angles are going to be like 55 degrees, 92 degrees, 33 degrees. And for the line segments P, Q, and R, this will be 12. That'll be Q will be 14.6, and R will be 8.